In this lesson, we're going to look at some more similar figures and talk about what we call scale factor. So if we're looking at these two trapezoids, and I tell you they're similar, if I ask you to compare WX and AB, what do you notice? Well, WX is 6 and AB is 3, so how do you transform AB to 6? You could add 3, or you could multiply by 2. If I'm multiplying by 2, this should bring you back to our first unit when we talked about dilations. Dilations are the only transformation that preserve the shape but not the size, right? So we are always using a scale factor to transform one shape into another. So the scale factor of two similar polygons is the ratio that will transform the first onto the second, right? So we're always going to be looking the new over the original. Just say no. So if we look at our shapes up here, our new size was 6, our original was 3, so our scale factor was 2, right? So our new shape is twice the size of our original, and if you look at the other sides, you'll notice that 2 times 2 is 4, 5 times 2 is 10, and 4 times 2 is 8. So it follows the same pattern for all of the sides. So now if I tell you that the following triangles are similar and ask for the scale factor, you again now just have to find a pair of corresponding sides and put our new over the original, right? So if I'm going this way, right? So I'm given Q, R, and P. So Q corresponds to T, R corresponds to U, and P corresponds to S. So here we're given 4, 40. So our new is 40, our original is 4. So there is a scale factor of 10. So if we want to practice finding the scale factor, the triangle on the right is a scaled copy of the triangle on the left. So this is our new, and this is our original. Express your answer as a fraction in simplest form, right? So here we can see they're both the same. So our new is 12, our original is 42. So all we have to do is 12 divided by 42 in simplest form. So you can use your calculator to simplify. So if we divide both by 6, we get 2 over 7. Because our scale factor is less than 1, our image is smaller than our pre-image. So again, new over original. This is the new, this is the original. And again, we're going to simplify. To divide both by 6, we get 2 over 5. Again, less than 1, so this is a reduction. The right is the scale copy, original. Now we have difference, so we want to make sure that we're choosing corresponding sides. So 20 over 16. We can, let's see, divide both by 4. 5 over 4. This is greater than 1, so this is an enlargement. New, original, 18 over 6, which is 3. So if we have some diagrams that have overlapping, the first thing that we want to do is to actually redraw the triangles. So I'm first going to draw KLP. So we have KLP. And then we're going to have KMN. Oh, wonky, but same thing. So KLP P, we have 8 and 12. For KM, we have 10 and 15. So we want to determine if the triangles are similar. So we have to draw the two triangles and then write out the ratios of corresponding sides or look for a scale factor, right? So if we're looking here, we know that 8 and 10 and 12 and 15, right? So if these truly are similar triangles, we would have to check and see if the ratios are the same, right? So our new is 10 over 8 for our purple, which would simplify to 5 over 4. For our orange, it's 15 over 12. Which are both divisible by 3. Had to think for a moment, which is 5 over 4. So they have the same ratio, the same scale factor, so the triangles should be similar. So if I was going to write a similarity, K matches with K, we matched KM and KL, and then we're left with N and P. So again, we'll write out our two triangles. So our smaller triangle is FRS. Our larger triangle is FED. So let's label. So the bottom here is 44. From here, our side is going to be 143 minus 91, which is 52. That side will be 88 minus 56, which is 32. And then we have 88, 143, and 121. So we have to see and look for the scale factor, right? So we know that 121 and 144 should be, so this simplifies to about 2.75. So if I check my other sides, 143 this gives me 2.75. And this gives me 2.75. So these are similar triangles. So FE matches with FR, and then we have S. A triangle has sides whose length are 5, 12, and 13. A similar triangle could have sides lengths of what? So remember, similar triangles you would multiply by a scale factor. So your sides would have to be multiples of 5, 12, and 13. So we couldn't have 3, 4, and 5. Let's see. 6, 8, and 10. No. Not 7. We're only going to be left with 4 because if I do 5 times 2, I get 10. I do 12 times 2, I get 24. I do 13 times 2, I get 26. So here they're giving us similar figures. So B corresponds to S, R corresponds to P, A corresponds to O, and T corresponds to T. The scale factor of BRAT to spot is 4 to 5. Find the length, the measure of missing sides. So we're only going to solve for x right now, just to keep it simple. So we know our scale factor is always new over original, right? If we call this new, so they're saying from BRAT to SPOT is 4 to 5. So this should be new. No, this is, sorry, we're starting from original to new. So new, original, so x over, so it's red to purple, so x over 14 has to be the same as 4 over 5. So 14 times 4 is 56, which is equal to 5x divided by 5 to get x is equal to 11.2. So we have a dilation with a scale factor of r, which ratio is equal to the scale factor. So here they're asking you, how would you determine the scale factor? So you would have to look and see what corresponds to what. Right? So this is our new, this is our original. So we would need to have a new side over an old side that is corresponding. So I can eliminate 4 because that has the original on top. So now we look for corresponding sides. So EF would have to correspond to BA. Those are both new sides. F is not even in the triangle ABC. So if we look, EF corresponds to BA. So if we look at your homework, so this is our new, original. If I'm looking for a scale factor, 8 over 12. Simplify, divide both by 4, we get 2/3. Triangle ABC. Okay, so now we're going to do some error analysis. So looking at these two triangles, we're going to see who found the correct scale factor. So if we look, we always have to do new over original. So right away, the first one's mistake, new, is on the bottom, right? So we can see this very clearly. So number 1 is immediately not good. This looks like it's set up okay. These two, A prime, B prime, B prime, B, those are not corresponding sides. Your letters should always be matching. And it's actually the same for Tom and Michael. So Whitney is going to be correct as long as she set it up correctly. So B prime, C prime is 2.2. BC is 11. This is the correct scale factor. Is this the same one as before? Yeah, this is the same one that from number 1. I don't know why it's there. That's a mistake on me. See above. Don't do it twice. Or do it twice. Whatever makes you happy.